record. Here we go. Okay, so let me see. I think I need just the initial information and then we'll just run through everything else. I need that much there. New page. Okay, so this is a hypothesis test. So this is application number 10. Many investors and financial analysts believe the Dow Jones Industrial Average gives a good barometer of the overall stock market. On January 30th, 2006, 9 of 30 stocks making up the Dow increased in price, according to the Wall Street Journal. On the basis of this fact, a financial analyst claims we can assume 30% of stocks traded on that day also went up, so that whatever happens on the Dow happens everywhere else. And then, okay, so up there, they're giving us some information. So on the basis of this fact, the financial analyst claims we can assume 30% went up that day. So what's our population? So population here, I know it didn't ask for this, but people are still having a hard time identifying a population in the parameter. Population is all stocks in the stock market. And the parameter here, which is the thing we're trying to measure in the population, parameter, is a proportion, 9 out of 30 or 30%. So the parameter here is the percent or proportion, in this case, of stocks that went up. Percent of stocks that went up in price. And the claim here is that it is 30%. So their claim, based on this population and parameter, is that P is 30%, 0.3. That has to be the null hypothesis because it has an equals in it. So next we got to read some more and figure out what the alternative hypothesis is. So a sample of 60 stocks traded in the New York Stock Exchange the same day and 31 went up. So this is sample data. So this is my N and this is my X. And together that's going to give me P prime, which is the favorable outcomes over total outcomes. So that's going to be 31 out of 68. Whatever that comes out to as a decimal. We want to conduct a study to see if the proportion of stocks that went up is significantly more than 0.3. So that's the alternative right there. Is the proportion more than 0.3? Okay, so we got our setup here. We have our alpha. So alpha is the standard 5% for mine. Yours may be different. So just drawing a quick sketch of this. I still have to calculate P prime and I have to calculate the standard error. So maybe I'll try using that spreadsheet that I just pointed out. So in the middle always goes the null hypothesis. And then I have to figure out how far is 1, 2, 3 standard deviations. In this case, I only care about the right because the greater than says this is a right tail. The alternative always tells you what kind of test to run. Okay, so let's try that spreadsheet I had. Show desktop, hypothesis test. Yep, let's open it in Google Sheets. And I'm gonna make a copy so I don't screw up your version. Zoom is in the way again. This is a proportion. And what is that sample data there? I don't think that belongs there. Take that out. That's not relevant to this problem because this is a proportion. That looks like sample data for a mean. Okay, I'm going to make a copy so I don't mess up your version. Sure. So then all I have to do is type in my information. And again, this picture down here is going to be irrelevant in a minute because I'm changing the data. So I'm just going to get rid of it. That was just a sample for this problem. So my P is not a not equal to, my P is a greater than, so I'm just going to replace that. And then the null is 0.3. So is the alternative. Significance level for me, they're not using that anywhere. Let's see, mine was 0.5. I might as well replace it so I don't get confused. Instead of 1%, sorry, 0.05. And this was, what did I have? 68 was my, nope, 31 was my number of successes. And 68 was my sample size. So this is, again, what we call X and N. And this right here would be P prime. Okay, so this is giving me my sample, my standard error, which is the standard deviation for the proportion here. So it's about 0.06. So let's go to my drawing that I started. So it's about 0.06. So one standard deviation to the right would be 0.36, and then 2 would be 0.42, and this would be about 0.48 approximately. And what did we calculate that was right there about, so we can see where it sits. It was about 46%, 0.456 sample proportion here. Put that in the drawing. So that's going to be kind of right in the middle here. So draw a line about there, that's where P prime sits, and that's about 0.456 in my example. And yours could be different. Yours could have been a significantly less or just not equal to, which means a two-tail test. So we want this over here, this region is my p-value. And the p-value means if somebody made a bunch of other samples of size 68, what percent of them would end up with a proportion that went up that's greater than 45.6%. And if this number is too small, that means there's something wrong with the null hypothesis. So remember, this is my null hypothesis, P, the population proportion. All right, so now we just need to calculate that, and StatKey can calculate this too. But we got it here. So they give us the p-value. This is a right tail, here we go. And this says that should be about 0.2%. Is that right? That doesn't look right on my picture. Huh. Did I screw up my picture? The standard error, did they do that right here? Yeah, that's the standard error formula. About 6%. This is 45. That's 30%. Oh, doesn't this look right on my picture? I guess I'll have StatKey draw the picture too. 30 plus 6% plus another 6%. Oh yeah, that's more than 2 standard deviations out. Yeah, because 2 standard deviations, right, that is 95% of the data is between, which the tail would then have about 2.5. Out here, the tail is about 0.5%. So yeah, that could be right. I'm going to double check in StatKey. And to do this in StatKey, I need the standard error here. Copy, and I'm also going to need this proportion and the, so 0.4559-ish if I went to 4 decimal places. This is a proportion again, so it's a theoretical normal distribution, and then I just have to put the right parameters. My null hypothesis is 0.3, and I copied the standard error, which is about 6%, and then I just need to do a right tail in this case and plug in my sample data, which was 0.4559 to 4 decimal places. And StatKey says it's 0.0025. Okay, so I drew my sketch just a little bit off. Maybe it should have been farther to the right. 0.0025. Okay, let's put that in there. So my p-value here is about 0.0025, which is pretty small, right? As a percentage, that's 0.25% is that p-value. That is small. It's way smaller than my alpha here. So the p-value is definitely less than alpha. And hang on one sec. All right, so this implies that we should reject the null hypothesis for mine. So let's see. Other thing I could mention here is what does the p-value mean? So I'll put that in writing. And then this is my, my decision. The conclusion is writing it up for my mom, say. So new page, we'll interpret the p-value and write a decision. So conclusion, oops. Conclusion, the decision again is just reject or fail to reject. The conclusion is where we write up a sentence. So, why can't I get that right? Conclusion would be something like, we have sufficient evidence that, and then we state what our parameter means, so that the proportion or percent of stocks that increased in value. And this is one reason I think it's important to upfront state what your population and your parameter is, because if you don't know those clearly, you can't make a conclusion. That the proportion of stocks that increased on this day is more than, so I'm just going to state the alternative next, 30%. Oh. And often researchers will state their p-value here, so I might make a little note, p-value, and then the individual reading, it could say, oh yeah, that's a small p-value. Now, if I want to interpret that p-value, that's a whole different question. So interpretation of p-value. And on a lot of the homework, you had to pick what was the best conclusion or the best interpretation. On the final, you're going to have to write this for me. So definitely practice this. So interpretation of the p-value. So there is a, if I turn that to a percent, 0.25, quarter of a percent chance or probability of finding another sample of 68 stocks for which more than, because it's a right tail test, and what was mine, about 45.6%, I think it was. 45.6%, more than 45.6% went up in value. When we were expecting only 30% to go up in value. So I'm just describing how I calculated the probability in a sentence my mom might get in value when we were expecting only 30%. And only is kind of a biased word. I probably shouldn't have put that in there. Only 30% went up. Let's see. Only 30% to go up in value. And again, I can't write these interpretations unless I clearly understand the parameter I'm testing here, I'm trying to measure. Okay, let's stop on that one.